All right, home plate for tonight is pages 433, 434, numbers 15 through 22 only. Get a Cornell note. You do need a Ferry model. I'm going to go over certain things to make sure that we get the whole idea. And last week we already started some of the practice and the warm-up. Thank you guys for doing all the warm-ups. Appreciate it. Okay. Once again, pages 433, 434, 15 through 22 only. Our objective for today, I can add and subtract rational expressions. Once again, I can add and subtract rational expressions. Today's a new concept, so make sure you get a Ferrier model going for rational expressions. Rational expressions. So what are rational expressions? Rational expressions are algebraic expressions whose numerator and denominator are polynomials. Rational expressions are algebraic expressions whose numerator and denominator are polynomials. Examples: 6 over g plus 4, 2x plus 1 over x squared minus 15x, 2x plus 6 over x squared plus 5x plus 6. Copy those. All right, here we go. Rational expressions, what are they? Algebraic expressions. Once again, thinking back to algebraic expressions at the beginning of the school year, what did we say they were? They were either numbers, variables, numbers and variables, or numbers and variables with operations. And this one has a numerator and a denominator, so obviously it's a fraction. And the last thing is that they have polynomials. Let's look at the examples. 6 is a algebraic expression. G plus 4 is an algebraic expression. It's in a fraction form, yes, and they're polynomials, yes. Look at this one and look at this one. Now that you see exactly what they look like, rational expressions, let me show you what they're not. Look at those before you copy them. Tell your neighbor why number this one and this one are not rational expressions. Leo, why? You ever hear that? Me neither. Because what? You ever hear that? Because they have equal signs. Yes. These are equations. And what are we looking at today? Expressions. However, this middle one, you can technically argue that it is irrational because we can write it over what? 1. But for the purpose of today, I put it over here because we're not looking at just those with over 1. I want to see stuff that has polynomials in the numerator and denominator. Okay? So with that said, let's hashtag this, especially those of you that like hashtagging, right? I see some of your hashtags and Instagram and all that. I'm like, oh my goodness. Let's see. Rational expressions, what are they? Hashtag what? Tell your neighbor, please. Hashtag what? Let's see. Kenzie, go. Them algebraic expressions. Pass someone. Remote. Denominator. That is correct. Pass someone. Ethan. No, damn, no equal sign. And I'll give you one last one. Hashtag polynomials. And remember, they're not going away. You're going to be headed toward donut to get a nice tea, and all of a sudden in the corner, return polynomials. There it is. All right, so rational expressions, we know what they look like, we know what they don't. So let's get started. Here we go. So Just to clarify, write your utensils down, look up to the screen. At the beginning of the school year, I gave you guys a definition for rational numbers. And I gave you guys this one. Focus, please. Rational numbers are the set of all fractions, do you see a fraction here? Where the numerator, m, is an integer, the denominator, n, is an integer, but the n cannot equal to 0. So what cannot equal to 0? The denominator, which is n. Okay? So today, when we're simplifying expressions and working on rationals, the denominator cannot be equal to 0. That's why today we're going to be doing a practice on what we call excluding values, or excluded values. What is an excluded value, Mr. Q? Excluded values are any value that makes the denominator equal to 0. For example, don't copy this, just focus. An excluded value. So if I was to give you the rational expression 5 over x plus 2, focus here, look up. What is my denominator? That one. Okay, think of a value that we can substitute into x that would make this whole thing 0. Tell your neighbor that value, please. Everyone? -2. -2 is what we call the excluded value. What does that mean, Mr. Q? That whatever we do with this, we cannot use what? -2. Why? Because then it makes the fraction where the denominator is 0. Why can't it be 0? Because this is not part of the definition of rationals. Does that make sense? We can use any other value except that one. That's why it's called excluded values. Okay? For the purpose of today, like I said, I'm going to break it down into simple steps. Today we're going to start with finding excluded values and simplifying rationals. We already started last week on the warm-ups. We did plenty of practice, but I'm going to mesh those two together. So check this out. Simple steps that I gave you guys this time just to follow are: number 1, to identify the excluded values, I write the denominator equal to 0 and solve. 2, to factor completely numerator and denominator, and then identify giant ones. These 2 steps we did last week on the warm-up. I'm going to leave those steps up there so that you can see what we're going to do with each problem. Okay? Copy this one, please. Example number 1. It reads, identify the excluded value. That's what we're doing. But then I want you to do something extra. What is it, Mr. Q? Simplify to lowest terms. 2 things we're going to do. Right now, just copy that, and I'm going to show you how to do those 2 things. Here today, 2 things. The first one, identify the excluded value. I'm sorry. Identify the excluded value. All right? You'll copy at the end. I'll give you time. Here it goes. First thing I'm going to do to find out what the excluded value is, it says here, I wrote it down in step no 1, write the denominator and write that equal to 0 to solve. Excluded value. Okay, I'm going to write 2x plus 6 equal to 0 and solve. So what do? -6 minus 6, 2x equals -6, divide by 2, x equals -3. Therefore, my excluded value is -3. Copy that. All right, any questions up to right there? So, if I was to ask you, finding the excluded values, do you know what to do? Set the denominator equal to 0, solve, and that's going to be our excluded value. Okay. But what if I ask you to do something else? The something else is to simplify to lowest terms. Write your pencil down, look up to the screen. To simplify this, we did this last week on the warm-up. And I said, to simplify this, we need to factor completely the numerator and denominator. So this one, it looks like it's already factored completely. I'm just going to write 2 times x. This one I can factor. Is there a certain factor for each term? Yes, 2, and I'm left with x plus 3. I'm already done factoring completely top and bottom. There it is. However, the last step to simplify to lowest terms, I need to identify giant ones. What does that mean, Mr. Q? Something over something that's identical. Do you see something identical? Yes, the 2 over 2. Now some of you are like wanting to do this, but we can't do this because this one's inside the parentheses and there's addition. Therefore, what do I have left? X over x plus 3, and I'm done. Why, Mr. Q? Because this one is addition, not multiplication. That's why we cannot do that anymore. Copy that, please. And that's simplest form. That's simplest form. So we did two things. What was the first thing? Excluded value. What is the second thing? Two lowest terms. Now, why do we need two lowest terms? Because today we're adding and subtracting rational expressions, and I want to make sure that you understand how to simplify because they're going to ask to simplify to lowest terms. Okay? But the key word here is number one, excluded values, and number two, factor completely to simplify. Okay? Some of you fingers how come you are with these? Okay? Let's see, you do one. That's it. Those are two things, just to get started. We're doing this practice first. Copy this one. All right, we're going to go a little bit faster. We're going to do this one together. So let's see. We got 6x over 3x plus 9. Let me take someone to help me get started. How about Chance? Not here. How about Lauren? To identify the excluded values, what do I do? Thank you. Denominator equal to 0, 3x plus 9 equal to 0, and solve. Minus 9 minus 9, 3x equals negative 9 divided by 3, x equals negative 3. So my excluded value is negative 3. Bless you. And if you're not sure about the excluded value, guys, you can always test it. How can I test it, Mr. Q? We'll substitute that in for x. What is 3 times negative 3? Negative 9. Does that add up to 9 to give us 0? Yes. So that's how you know that it's the excluded value. So we're done with the excluded value. Now what are we going to do? They're asking us to do simplify to lowest terms. Has someone, Lauren? Jacob. To start simplifying to lowest terms, what do? It says here factor completely numerating denominator. So how can I write this in factored form? 2 times 3 times x. That is correct. How about the denominator? Is there a GCF? Which is 3 parentheses x plus 3. And then from there we just go to the last step and identify the giant 1. So we're left with 2x over x plus 3. Somebody else come to right there? Okay, let's crank it up a notch. All right, here we go. Copy this one. Example 1, super Q, we got x squared over x squared minus 5x. Once again, we're finding or identifying the excluded values and simplifying. All right. Jacob, pass it to someone. Abraham, tell me what to do for the excluded value. Okay. Equal to 0. Okay. So now that we're here, look at it. We have a binomial. In order for us to solve this quadratic, from this point forward, since we're going to be dealing with rationals, I want you to think about the word factor. If you notice here, it's factor, factor, factor. So how can we factor this? Think about it. Power Rangers, we need a third term, don't we? However, can we identify the GCF? What's GCF? X, and we're left with x minus 5, and all that equals to 0. Let me zoom in. Now that we have two factors, can we set each one equal to 0? Yes. X equal to 0. X minus 5 equal to 0. Solve. This one's already solved, so I add 5. X equals to 5. And now I have, instead of 1 excluded value, now I have 2. My excluded values are 0 and 5. All right. So we're done with excluded value. Let's simplify. I'm going to go to step 2. What does it say? Step 2 says factor the numerator and denominator completely. All right. Look at the numerator. What can we? How can we rewrite this? X times x. That is correct. And how can we factor this one? Didn't we factor it already? Yeah, it's over here. So we just write what? X parentheses x minus 5. Now that we're done, let's identify a giant 1. Do you guys see it? Yes, right here. So we're left with x over x minus 5. Show me what we're talking for you up to right there. Okay, we got it, right? See if you can do one by yourself. Ready? Here we go. Copy that. Example 1 mega cube. It reads 2x over x squared plus 7x. Once again, identify the excluded value and simplify to lowest terms. Copy that and go. All right, here goes the work for the excluded value. Who got excluded values are 0 and 7. Hence, okay, yeah, 0 and negative 7. There they are. Okay, let's go to the simplification. We can write the numerator as 2 times x, and this one is x times x plus 7. So far, so good? And from there, identify a giant 1. There it is, and we're left with 2 over x plus 7, and we're done. Hands if you got that. Okay. Yeah, we got this, yes? Let's crank it up a notch. Woo! Let's go. Example 1, super duper cube. We got 6x squared minus 6x over 3x minus 3. 6x squared minus 6x over 3x minus 3. All right, Abraham, pass someone. That, to find the excluded value, what do I do? And then we solve. Plus 3 plus 3. 3x equals 3. Divide by 3. X equals 1. All right, so far so good. Pass someone. Leo, to simplify, what do I do first? GCF, what's GCF for the numerator? 6x, that is correct. 6x, and we're left with x minus 1. How about the denominator? 3, and we're left with x minus 1. However, look up, guys, really quick. Can we factor the 6 more? We tell you never how to write it, please. 2 times 3 times x minus 1. That is correct. And this one stays the same. 3 times x minus 1. All right. Now let's identify the giant 1s. Do you guys see the giant 1s? This one and this one. What do we have left in the numerator? 2 and x, so that is 2x. Anything on the denominator? No, and we're done. Yeah. There's the whole thing. All right. Let's do another one. See if you can do this next one by yourself. Ready? Here we go. Example 1, Shazam cube. We got 8x squared plus 16x over 2x minus 2. Copy that and go. Yeah, excluded value is 1. Hands if you got that. Okay. Let me go to the simplification. Here it goes. What's GCF for the numerator? 8x. We're left with x plus 2. What's GCF for the denominator? 2. And x plus 1. However, bless you, can we rewrite 8 into more factors? Yeah, what are my prime factors? 2 times 2 times 2 times x plus 2 over 2x minus 1. Okay. So far so good? Identify the giant 1s, if there are any. About 2 over 2, yes. And are there any others? No. So therefore, that leaves us with, what is 2 times 2? Times x, 4x. Bring down the x plus 2. How about the denominator? All we have is x minus 1. There you go. Show me if famous outcome DR from 1 to 5. Where are we at? 4, 5, 4, 5, 4, 5. Okay. Y'all ready? Crank it up a notch. All right. Let's crank it up a notch. Here we go. Example 1, Star Wars Q. X squared minus 4 over x squared plus 3x plus 2. Let's go. Who went last? Leo, pass someone. Michelle, how do we find the excluded value? Set the denominator equal to 0. X squared plus 3x plus 2 equal to 0. Pass someone. Sebastian? Okay. Sebastian, how do we solve that one? The x factor. Oh, power. 2 on top, 3 on the bottom. Factors of 2 that add up to 3. 1 and 2. We rewrite this. X squared. And then instead of 3x, we write what? 1x plus 2x. Then the last term is plus 2. And we group. Group. GCF is x. We're left with x plus 1. GCF here is 2. We're left with x plus 1. So my factors are x plus 1, x plus 2, and all that equal to 0. Am I done? No. Set each factor equal to 0. So we got x plus 1 equal to 0, x plus 2 equal to 0, minus 1 minus 1, x equals negative 1, minus 2, x equals negative 2. And these are my excluded values. Let's write them in here. Negative 1 and negative 2. Those are my excluded values. Okay? Let me zoom out. All right. From there, now we need to simplify. Sebastian, pass someone. Ramon. So it says here factor completely. What are the factors for x squared minus 4? Okay, x times x, okay. Negative 2 times 2, that is correct. X minus 2, x plus 2. So he saw that it was a difference of squares, okay. Guys, and do we have the factors for this one already? Yeah, they're down here. So we just write them there. X plus 1 and x plus 2. Now that we're done with factoring, what is the last step? Identify giant 1. So you guys see it? Yeah, it's right here. So that means this becomes x minus 2 over x plus 1. I know, right? Be nice. So far, so good? All right, copy this next one. See how you do by yourself on this next one. Example 1, Michael Jordan Q. We got x squared minus 3x minus 4 over x squared minus 4. Find me the excluded value and simplify to lowest terms. Copy that and go. All right, check your work. Excluded value, negative 2 and positive 2. Hands if you got that. Okay, we got this. All right. Now let's go to simplifying. Who went last? Ramon, pass someone. Kenzie. What do I do with a numerator? Power Ranger thing. We got negative 4 and negative 3. Factors of 4 or negative 4 that add up to negative 3. 1 and negative 4. That is correct. Thank you, Kenzie. So let me rewrite this. This is x squared, and then we got 1x minus 4x, and the last term is negative 4. Therefore, Group. GCF here is x. We're left with x plus 1. GCF here is negative 4 and x plus 1. So what are my factors? X plus 1 and x minus 4. Factors of the denominator, do we have those? Yeah, they're right here. What are they? X plus 2, x minus 2. All right, now that we have everything completely factored, can you identify any giant ones? No, that means we are done. That's simplest form. Yes? Yeah, so for some of these guys, for example, Perla said, Mr. Q, can I solve this one using square roots? Yes, you may. X squared minus 4 equals 0, plus 4, we end up with x squared equals 4, square root, x equals plus minus 2. Yes, however, to save time, what do we need for this when we're simplifying? We need what? Factor. So what method do you think you should use? Factor. So like that, you already did the work here. But yeah, you can solve like that. All right? All right, show me with your fingers how comfortable you are with these. Okay, so we're done with simplification and excluded values. Let's crank it up about 5 notches, yes? All right, here we go. So, steps to add and subtract. Pay attention to this. Step 1, to adding and subtracting, I need to make sure that there is a common denominator. Listen to this. I need to make sure there's a common denominator, but if there isn't, I need to factor the denominators completely and identify the LCD, or the least common denominator. Let me repeat that again. First, check to see if it has a common denominator. If it doesn't, I need to factor completely the denominators to identify the LCD. Number 2, rewrite each fraction, then add or subtract. Pretty simple. Step 3, simplify after identifying giant ones. We've done that. And the last thing I'm going to add is identify the excluded values. Do we know how to do excluded values by now? Yeah, so right now we're not going to worry about the last one, but I want to focus on addition and subtract. Okay? We're going to start with one that has common denominators. Let's see how we do with that. Copy this one. Example number 2. It says add or subtract. We got x plus 5 over x squared minus 9 plus negative 2x minus 2 over x squared minus 9. So it's addition, and we have 2 fractions. Okay. Question, do we have a common denominator? Yeah. Yes, so at this moment, I don't have to factor each one. I just write one denominator for both fractions. What's the denominator for both fractions? X squared minus 9. So we make both fractions into 1. So now all I have to do is concentrate on the numerator and focus on combining, because this is what? Addition. So let's see, what is x at negative 2? Negative x, that is correct. What is 5 and negative 2? Positive 3. Does this look familiar? Yes, Mr. Q, it's like the one we were practicing earlier. Yeah, now we can simplify. So, let's factor the numerator. What's the GCF here? Negative 1. We're left with x minus 3. What are the factors for x squared minus 9, everyone? X plus 3 and x minus 3. That is correct. Identify the giant one. There it is. What do I have left? Negative 1 over x plus 3. That's the sum, but it's simplified to lowest terms. Do I need to do the excluded values? No, you already know how to do that. Is that correct? All right, move on to the next one. Yeah. For the excluded value, once you find the common denominator, use that denominator. Tell you never what I just said. For the excluded value, what? Which one do I use? The common denominator. What was the common denominator? This one right here. Yeah? All right, copy this one. Example 2Q. X minus 7 over x squared minus 25 plus negative 2x minus 2 over x squared minus 25. See if you can add that one by yourself. I'll give you some time. Copy that and go. All right, did we have a common denominator? Yes, it stays as 1. I combine these. I end up with negative x minus 9. GCF for these two is negative 1, so we have negative 1 times x plus 9. Factors of x squared minus 25 is x plus 5x minus 5. Can we identify any giant ones? No, so it stays like that, and we're done. Can we walk through the yard with common denominators that are the same? Okay, we got this. 5 4 5 4. Let's crank it up a notch. Here we go. Copy this one. We got x squared over 4 minus x squared minus 1 over 2 minus x. All right. Do we have a common denominator? No. Now at this moment, we have to factor the denominator. So let's see. What is what are the factors for this one? Isn't it difference of squares? Yes. 2 minus x and 2 plus x. Is there a GCF here other than 1? No, I just write 2 minus x. So pay attention to this one. Look up to the screen really quick. What do you notice that this one has that this one doesn't have? Plus 2. So we write 2 plus x, and we multiply not only the denominator, the numerator also. 2 plus x. So now my new common denominator is, parentheses, 2 minus x, 2 plus x, and then we're going to combine whatever is in the numerator. What do we have? X squared, and then we have 2 plus x times negative 1, so that is negative 2 minus x. You can see what I did here, because there's a negative, so I needed to distribute to both of these right here. Okay, so is this in standard form already? No, I write x squared minus x minus 2 over 2 minus x and 2 plus x. So here, what's the next step? Power rangers, negative 2 and negative 1. Factors of negative 2 that add up to negative 1. 1 and negative 2. That is correct. So to save time, look, I'm going to use the shortcut. Look up. I'm going to write x plus 1 and x minus 2. Are we there? Yes, Mr. Q. All right. I bring these over. 2 minus x and 2 plus x. So far, no. But we need to rewrite this one to look like this, don't we? All right. So let me turn this around. Look up. I'm going to turn this one around and write negative 2 plus x. Do you see how I wrote this one there and that one there? Does it look almost like these? Except that the 2 has a what? So we factor out a negative 1. Here we go. This, I'm going to factor out a negative 1. That leaves me with what? 2 minus x. Okay, so watch. So this became this. Yes? All right. So let me scoot over this way. There it goes. So what do I have in the numerator? I have this one, x plus 1. What else do I have? Negative 1 times 2 minus x. What do I have in the denominator? 2 minus x. And what else? 2 plus x. Do you see the giant 1 now? Yes. Yes. What is it? 2 minus x. All right, so if that's true, we got negative 1 x plus 1 over 2 plus x. Yeah, I know. They're getting funner, aren't they? Yeah. Nice. And by the way, here's multiplication also. I'm going to put this like that. We don't think it's addition or subtraction. All right, let me zoom out. Okay? All right. What if it looked like this? Copy this one. Last one. Copy that one. Example 2, Shazam cube. We got 5x plus 30 over, bless you, x squared minus 13x plus 42 plus 11 over x squared minus 6x minus 7. You see how all the home plate's paying out now? Pretty good, right? What? People copy? All right, here we go. Do we have a common denominator? No, that would be nice. No, that means we need to factor this one. 42, negative 13, product, sum. Factors of 42 that add up to 13. Let's first, 6 and 7, but they need to be what? Negative. Negative 6, negative 7. I'm going to use shortcuts so that we don't do by grouping to save time. So one of my factors is x minus 6, and the other one is what? X minus 7. Okay, we got that. Let's go to the next one. Negative 7 and negative 6. Factors of negative 6 that add up to negative 6. Factors of negative 7 that add up to negative 6. 1, negative 7. So my factors are x plus 1, x minus 7. All right. So, do we have a common denominator? No. But check this out. What does this have that this one doesn't? X minus 6. So I need to multiply this times x minus 6. And whatever I do to the denominator, I do to the top numerator. That is correct. So we need to make this one look like this one. What does this one need from over here? X plus 1, x plus 1, x plus 1. There it is. Hold on. Last thing before you go. So now we have a common denominator. We write these all together. X plus 1, x minus 6, x minus 7. And then we distribute whatever that trinomial here plus whatever this is distribute. And then we simplify, factor, and simplify again. Okay? Let's see how you do with a home plate, guys. Things are home plate. They're pages 433 and 434. Numbers 15 to 22 only. 15 to 22 only. Have a good one, guys. See you guys tomorrow. Bye. Yeah, tune in today. It's free.